So today in front of us we have 25 times 10. The problem is written on the blackboard. However, if you want to excel in math, I highly recommend that you get a sharp pencil and you do your math problems on a graph paper. So here on this graph paper we rewrote 25 times 10, and let's get down to it to learn how we do the system. So the first thing we do is we take 0 times 5, and then we're going to take 0 times 2. So when we take 0 times 5, the answer is 0. When we take 0 times 2, the answer will also be 0. The next thing we do is we put a 0 right up here. And then we go 1 times 5, and the answer will be 5. Then we take 1 times 2, and the answer will be 2. Then we add the double zeros plus 250, and we always start with the right column. So 0 plus 0 will be 0. 0 plus 5 will be 5. 0 plus 2 will be 2. So the answer is 250. So we got two factors. Factor times a factor equals the product. 25 times 10 equals 250. Also, to excel in math, you always double check, if not triple check, your work. Now, you could always use a calculator, but imagine the high possibility that you will end up on some remote island where you may not have a calculator. So one of the ways to check your work is you flip-flop the factor. So instead of 25 times 10, it's going to be 10 times 25. And the same thing, we take 0 times 5, which will be 0. Then we take 5 times 1, which will be 5. We then put the 0 right up here. And then we go 2 times 0, which will be 0. 2 times 1 will be 2. We then add them up, and we always start with the right column. 0 plus 0 equals 0. 5 plus 0 equals 5. 0 or nothing plus 2 will equal 2. The answer is 250, so they do match. So here we have 25 times 55. Once again, we're going to take 5 times 5, and the answer will be 25. Now, we do not write 25. We only write the second digit, which is the 5. And the 2 we carry to the top and put it over this 2. Next, we take 5 times 2 plus 2. And 5 times 2 is 10, plus 2 will be 12. And we put 12 right up here. Then we put the 0 right up here. Or you could leave it blank, but put the 0 for now. And next we're going to take 5 times 5. And once again, the answer is 25. But we only put the second digit, which is the 5, and the 2 we carry on top. And cross out the previous 2 because we don't need it. Then we take 5 times 2 plus 2, and we know that 5 times 2 is 10, plus 2 will be 12. And this time you write both digits, 12, right up here. Next, we add them up. And of course, we start with the right column. 5 plus 0 equals 5. 2 plus 5 equals 7. 1 plus 2 equals 3. 0 or nothing plus 1 will equal 1. So 25 times 55 will equal 1,375. Factor times factor will equal the product. And of course, let's review. Remember, to excel in math, you have to double check, triple check your work. Of course, you could use a calculator, but what if it's Christmas break and you left your calculator in school in your locker? What if it's a dark winter night and the solar little cell on your calculator does not work? Or perhaps you flushed your calculator down the toilet by mistake. So there's always going to be situations where you might not have a calculator. Your mom might take away your smartphone, which has a calculator on it. So this is why you have to do it manually. So once again, we will flip-flop the numbers, put 55 on top and 25 on the bottom. We then take 5 times 5, which is 25. The 5, the second digit, we put right here, and the 2 we carry on the top. Next, we take 5 times 5, which is 25, plus the little 2 on top, which will make it 27, and we put the 27 right up here. Next, we do the second set of numbers, and always remember to put the little 0 right up here, or you can leave the space blank, but I recommend you put the 0. Next, we take 2 times 5, which will be 10. Now, we only put the second digit, the 0. And the 1 we carry on top and cross out the previous 2. So then we take 5 times 2 plus the little 1 on top, and that will be 11. And we put the 11 right up here. Both of the digits we write here. Last but not least, we add them up. And of course, we always go to the right column. So 5 plus 0 will be 5. 7 plus 0 will be 7. 2 plus 1 will be 3. And nothing plus 1 or 0 plus 1 will be 1. The answers match. Both sets, the answers are 1,375.
Hi, welcome to Math Antics. In this lesson, we're going to learn about negative numbers. Negative numbers can be a little confusing at first, so don't get discouraged if it takes you a while to get it. To learn what negative numbers are, we first need to start with whole numbers. You remember what whole numbers are, right? They're the set of numbers on the number line, starting with 0 and then counting up one at a time, 1, 2, 3, 4, all the way to infinity. That's a lot of numbers, but it's only half the story. And that's because the number line really goes in both directions. You're used to seeing the number line starting at 0 and just going to the right. But the number line also goes to the left. And what numbers are on that part of the number line? Yep, you guessed it, negative numbers. The negative numbers are just like a mirror image of the numbers on the right side of the number line that we call the positive numbers. And 0 is the special number that separates the positive numbers from the negative numbers. By the way, when you combine all these numbers, 1, 2, 3, and so on up to infinity, and -1, -2, -3, and so on, down to negative infinity, and the number 0, that entire set of numbers gets a special name in math. They're called the integers. As you can see, the negative numbers look just like the positive numbers. The only difference is that they have a negative sign in front of them. The negative sign looks just like the minus sign. In fact, if we wanted to, we could write a positive sign, a plus, in front of all the positive numbers. But to save time, we just assume that if a number doesn't have any sign in front of it, then it's positive. Positive is the default sign. Okay, now that you know what negative numbers are, we need to learn how to compare them to other integers. Remember that in math, comparing just means saying which of two numbers is bigger or smaller than the other, or saying that they're equal. And to do that, we use the greater than less than, or equal signs. You're probably already pretty good at comparing positive integers. Like if I ask, which is bigger, 2 or 3? You know that 3 is bigger than 2. But what if I ask you to compare two negative integers? Which is bigger, -2 or -3? This is where negative numbers can be a little tricky, especially if this is your first time learning about them. That's because you're so used to 3 being bigger than 2 that when you see -2 and -3, it's really tempting to think that -3 must be bigger than -2, but it's not. -3 is actually smaller or less than -2. And to help you understand why, let's look at our number line again. Have you noticed that if you start at 0 on the number line, and then you move to the right, the numbers keep getting bigger and bigger as you go along? 1 is greater than 0, 2 is greater than 1, and 3 is greater than 2, and so on. But what if we go in the opposite direction instead, to the left? As we go to the left, the numbers get smaller and smaller. 2 is less than 3, 1 is less than 2, and 0 is less than 1. Well, those same exact rules apply to the negative side of the number line also. The numbers get bigger as you go to the right, and they get smaller as you go to the left. So, since -3 is on the left side of -2, it's actually smaller than -2. I like to think of it like this. On the positive side of the number line, 3 is more positive than 2, so it's bigger. But on the negative side of the number line, -3 is more negative than -2, so it's smaller. And you can use that idea no matter what the numbers are. On the positive side, 500 is more positive than 200, so it's bigger. But on the negative side, -500 is more negative than -200, so it's smaller. Keep that in mind if anyone ever offers to give you -$500. The 500 part sounds pretty good, but the negative part, not so much. Alright, so the positive integers are on the right side of 0 on the number line, which means they're all greater than 0. And the negative integers are all on the left side of 0 on the number line, which means they're all less than 0. Wait, hold on a second. Less than 0? How can any number be less than 0? I mean, doesn't 0 mean nothing? That's a good question. At first, it can be hard to see how there could be numbers that are less than 0. But here's an example that will help you understand. Let's say we want to use integers to measure how many meters above sea level small islands are. This island is 10 meters above sea level. This island is only 5 meters above sea level. And this island here happens to be exactly the same height as sea level. So we can use the integer 0 to show how its height compares to sea level. But what about this island? It's not even above sea level at all. It's 5 meters below the surface. But our measurement is supposed to tell us how many meters above sea level it is. Fortunately, with negative numbers, that's no problem. We can just say that its height, compared to sea level, is -5 meters. Or, what about an example with money? Suppose there's 3 brothers who each have a different amount of money. The first brother has $20, the next brother has $0, and the last brother actually owes his dad $20. What number do we use to represent how much money he has? Yep, -$20. And temperature is another great example. We use 0 degrees Celsius to describe the temperature for water to freeze, but it can be warmer or colder than that. The temperature could be negative, like -20 degrees. So negative numbers are very useful in the real world to help describe things that can be above or below 0. Okay, now that you know how negative numbers work, let's see how we can compare any two integers. If we don't include 0 for a moment, basically there's just 3 situations. You'll either need to compare 2 positive integers, or 2 negative integers, or 1 positive and 1 negative integer. And you already know how to compare 2 positive integers. The further right on the number line you go, the bigger the numbers get. 7 is greater than 4, 50 is greater than 20, and 1,000 is greater than 100. It's also really easy to compare a positive integer and a negative integer, because a positive number is always bigger than a negative number. All of the positive numbers are on the right side of the number line, and all of the negative numbers are on the left. So -5 is less than 5, and -40 is less than 3, and negative 100 is less than 1. The only tricky situation is when you have to compare two negative integers. Then you have to think about which one is further to the left on the number line. Again, a great way to do that is to identify the number that would normally be more positive on the positive side of the number line and realize that it's more negative on the negative side. Negative 8 is more negative than negative 4, so it's smaller. Negative 15 is more negative than negative 10, so it's smaller. And negative 100 is more negative than negative 25, so it's smaller. All right, so in this video, we learned what negative numbers are and how they can be used to describe things in the real world. They're just like positive numbers, but on the other side of 0 on the number line. And we learned that the whole numbers, along with their negative counterparts, form the set of numbers we call integers. We also learned how to compare integers. As you go to the right on the number line, the integers get bigger, and as you go to the left, they get smaller. Comparing integers can be confusing at first, so be sure to practice until you've really got it. As always, thanks for watching Math Antics, and I'll see you next time.
Negative numbers are any number less than 0. Imagining something less than 0 can be difficult. Suppose you have a bowl of oranges, and someone takes them away until you have 0 left. When there's nothing, it's hard to imagine being able to take away more. However, there are instances in real life where we use numbers less than 0. For example, did you know the average temperatures at the top of Mount Everest range from negative 19 degrees Celsius to negative 36 degrees Celsius? Wow, that's cold! Negative numbers also appear a lot in finances to show debt. Suppose you have $50 in your bank account, but then you accidentally spend $60. Your account's balance is now negative 10. This means you owe the bank $10. To understand negative numbers even more, let's look at a number line. For every positive number, there is a negative number. Negative numbers can also be thought of as the opposite of a positive number. So, the opposite of 5 is negative 5. You might also notice that as we go further down the number line, the negative numbers appear to get larger. However, the numbers are really getting smaller. For example, negative 10 is smaller than negative 5. This can be confusing, but think about it in terms of temperature. Suppose on a winter's day it's negative 25 degrees Celsius in Barrow, Alaska, and negative 35 degrees Celsius in Stanley, Idaho. Stanley would be colder than Barrow because negative 35 is lower than negative 25. Now you know the basics of negative numbers.